So a student sent me a question about exercise 8-22, from the book. And of course, this is one of your Connect problems in chapter 8. And I want to share this with you because I just love the way that this person submitted the question and told me about the problem. And it also may be something that you need to be aware of. So I'm going to make this available to everyone. This person says, I keep getting stuck on the problem from the homework, and the problem is, and this person did a great job of copying and pasting this, and it says, in the Department of Education at UR University, student records suggest that the population of students spend an average of 5.4 hours per week playing organized sports. Now I've labeled this mu equals the 5.4, mu being the population average. So that's perfect. The population standard deviation, sigma, 2.6 hours, okay, based on a sample of n equals 121, okay, so n, that is labeled n, very good, would like to apply the central limit theorem to make various estimates. Compute the standard error of the sample mean. Now, the standard error of the sample mean is sigma sub x bar, right? And that actually is the formula sigma divided by the square root of n. So this student says, I have determined that the standard error of the sample, by taking 2.6, and that's sigma, and that's exactly right, and then the square root of 121. And that, again, is exactly right. And they say, and getting the answer 0.24. Now, I checked that in Excel, doing some other things here as well, but checked that in Excel, and 0.24 is exactly the right answer, so I can check that off. I know this person has done exactly what they need to do there. Now, it says the next part of the question is that they want to find the sample mean between these 2 points, x1 of 4.6 and an x2 point of 6.2 hours. They say, I keep getting stuck right here. Oh, I love this sentence. I made a sketch of the graph. Perfect, perfect, perfect. It says, I use the equation to find the z value when the population standard deviation is known. Now look at what this person is doing, and this is exactly right. They are telling me their calculations. I can double check each part of this. 4.6 is x, 5.4 is mu, divided by 2.6 divided by the square root of 121, and that is perfect. It says I'm getting an answer of negative 3.38. I checked that in Excel. Exactly right. Then they use the other point, 6.2 minus the 5.4, again divided by 2.6 divided by square root of 121, and that's our formula for sigma sub bar. It says, and I'm getting positive 3.38. Okay, also correct. I double checked that. And they say, can you point me in the right direction? Well, now here's where the problem is. What we would do at this point is we would look this z value up on our table so that we could look at the probability. But when we do that, here's the table, we see that our table only goes up to 3. And the number that has been calculated and is calculated correctly is 3.38. So this is a situation where you're just going to have to use your calculator, and to me, the fanciest and easiest, best calculator to use is perhaps Excel. Okay, now I was playing around with some of these. Let me come to this. This is our norm dist function, and you learn how to use this in the extra credit. Okay, but I've typed this in, norm dist. The x value is 4.6. The mean is 5.4. 2.6 is the standard deviation. We know that logically this is true. The answer is true, that it is continuous, right, or cumulative. And I come up with 0.3792. Okay, so I would actually probably retype that to avoid rounding errors later on. So 0.3792. Now, what you have to remember as you do this with technology is, where is this area? And I have already drawn a picture here. And remember, we started with the point 4.6. Now, 4.6, it's the area to the left of this, to the left.